Hello everyone, in this video we are going to know about the DDCO Lab experiment number 3, that is design Verilog HDL to implement binary adder subtractor off and full adder off and full subtractor. It means we have to design a Verilog HDL program to implement off adder and off subtractor and full adder and full subtractor. Let's begin with off adder circuit. Here the truth table is the truth table for off adder circuit. We have considered inputs and outputs, and A and B are the inputs and carry out and some are the outputs. Let's first fill the inputs 0 0 0 1 1 0 1 1. So when we add 0 and 0, when 0 plus 0, sum becomes 0 and carry out becomes 0. When we add 0 and 1, sum becomes 1 and carry out becomes 0. When we add 1 and 0, this is same as this. Sum becomes 1 and carry out becomes 0. When we add 1 and 1, sum becomes 0, carry out becomes 1. This is the circuit diagram for off adder circuit. Here where 1 is present in the sum, we have to consider that inputs. So in second one, first position, here the 1 is present, so we will consider this inputs. So it becomes A bar B. So the gate for that A bar B is this one, and here 1 is present, so we will consider this input, which becomes AB bar. So in the gate for the AB bar is this, and where the carrier 1 is present in the carrier, we have to consider that inputs. Here the 1 is present in the carrier, so we will consider it becomes AB. So the gate for this is AB. So finally we can write that sum is equal to, here 1 is present, so this input becomes A bar B, plus here 1 is present, so this equation becomes AB bar, and carry out is equal to, here 1 is present, so this becomes AB. Now let us begin with full adder circuit. So the truth table for full adder, we have taken three inputs A, B and C, and outputs are carry out and sum. When we add 0 plus 0 plus 0, the sum is 0 and carry out is also 0. When we add 0 and 0 and 1, the sum is 1 and the carry out is 0. When we add 0, 1 and 0, the sum is 1 and the carry out is 0. When we add 0, 1 and 1, the sum is 0 and the carry out is 1. When we add 0 and 0, the sum is 1 and the carry out is 0. When we add 1, 0 and 1, the sum is 0 and the carry out is 1. When we add 1, 1 and 0, the sum is 0 and the carry out is 1. When we add 1, 1, 1, the sum is 1 and the carry out is 1. All this through K-map. First we consider carry out. Where 1 is present in the carry out, we have to consider that. First we will draw two variable K-map. Here we have to take, there are three inputs, so here we take A, B, C in. Here 0 1 0 0 0 1 1 1 1 0. So here first the carry out, here 1 is present, so it becomes A 0 B 1 C in 1. So A is 0 here, B is 1 here, C in 1 here. So it become, we will put 1 here. Next here A is 1 here, B is 0 and C in is 1. A is 1 here, B is 0 here, and C in 1. Next, we will consider this. Here A is 1, B is 1, and C in is 0. So it becomes here. So last, the sum here carry out is 1. So it becomes A 1, B 1, C in 1. So it comes here. So let us group according to the K-map rules. This two becomes group, this two becomes group, and this two becomes group. So first we will name this group. Here A is not changing, so we will consider A, and B is changing, so we will not consider B, and C in is not changing, so we will consider C. Next A. Next here B is not changing, so we will consider B. Next this group, here A is changing, so we will not consider A, and B, C in. So the final carry out expression is AC in plus AB plus BC in. So in same way we will do it for sum. So we will draw first K map. A B C in 0 1 0 0 0 1 1 1 1 0. So where there is one, we will consider that here one is present. So it becomes A bar B bar C in. So 0 0 1. Here one will come next. Here next A0 B1 C0 A0 B1 C0. Next A1 B0 C0 A1 B0 C0. This one. Next A B C in this one. So we will not notice that there is there is nothing, there is any possibility of grouping, so it will come single pair. So the final expression of this K map is A XOR B XOR C in. So this is the circuit diagram for full ladder circuit. As we can see that in some expression it given that A XOR B XOR C. So AB XOR C in XOR according to the expression we are drawn a circuit. Next, when we come to the C out circuit, here AC in. So this is the gate of AC in, and AB, this is the gate of AB. This will combine to give a OR gate, and the final expression is being seen. So this is this AND gate and this OR gate will come to give another OR gate. So this is the circuit of full ladder. Discuss with off subtractor. So this is the inputs and outputs. Here inputs are X and Y and outputs are B out and difference. So first write inputs 0 0 0 1 1 0 1 1. When the inputs are 0 0, the difference will be 0 and the bar out will be 0. When the inputs are 0 and 1, the difference will be 1 and the bar out will be 1. When the inputs are 1 and 0, the difference will be 1 and the bar out is 0. When the inputs are 0 and 0, the difference will be 0 and the bar out will be 0. This is the circuit diagram of off subtractor. Where 1 is present, we will consider that inputs. So in difference, here 1 is present, so it becomes X bar Y. So the circuit gate for that X bar Y is this one, and we here 1 is present, so we will consider this inputs, it becomes XY bar. So the gate for that XY bar is this one, it will combine to give one OR gate. So when we consider bar out, here 1 is present, so it becomes YX bar. So we have written a gate diagram for bar out here. So this is the Verilog HDL program for off adder and subtractor. We have taken module and we have named this as off adder and subtractor, and here AB are the inputs and some carry out difference and bar out are the outputs. So as from the syntax, we have written input AB and output are sum, carry out, difference and bar out. First we have written a program for off adder. It becomes assign sum is equal to A XOR B, and next assign C out carry out is equal to A and B. This this program is written on the basis of the expression we have got from after solving the truth table. Next we have written program for off subtractor. Assign difference is equal to A or XOR B, and assign B out is equal to not A and not B and end module. So let us write program for Verilog program for full ladder and full subtractor. First we will start with module. Let name this program as full AS, and the inputs are A, B and C. In here there are three inputs and outputs are sum, carry out, difference and bar out. First we will write for first we will write inputs A, B, C in are the inputs, and the output are sum, carry out, difference, bar out. So first we will write Verilog HDL program for full ladder. So it becomes assign sum. As we note that we have got an expression after solving KMAP. From that expression it becomes assign sum A power B, so A XOR B XOR C in, and we will write for assign carry out A and C in, or A and B or B and C in. So by the same way we will write program for full subtractor. First we will consider difference. Assign difference is equal to A XOR B XOR B in. When we will consider now for bar out is equal to B and B in or not A and B or not A and B in. So this is the Verilog HDL program for full adder and subtractor. So thank you.